Lesson 6.3 is on making comparative inferences about populations. We're going to start out here on page 330. There will be some things that the book has statements and things that I'm going to either modify or completely disagree with, so make sure you keep track of what we're doing. So if you look at example 1, Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, then list the data in order from least to greatest. What can Finn notice about the time spent on homework? And just so you're not worried about these students, this is the number of hours they spend on homework each week. Okay? So in case anybody was worried about the 11 hours of homework there, that's for the week, not for the day. All right? So what they did is they took the information and they made box plots. Making box plots, again, we did this last year, but just refreshing your memory on that real quick. Basically what we have is the lowest number goes at the bottom part of our box plot or box and whisker plot. So that's called the minimum a lot of times. That's the lowest number. The maximum or the biggest number goes at the other end. And you really, when you make these box plots, you have to figure out all this stuff first before you just draw the box plot. Where the two boxes meet, that's the median. And then we already talked about the other day, in a box plot, each section represents about 25%. So if you think about, think about the medians right in the middle, 50% about is below that, 50% is above that. So to get 25% in each group, well, we have 50% below the median. If we find the median of the stuff below the median, that'll split our 50% in half, which will give us 25% in each group. So that's where they get this number. So that's called the first quartile or lower quartile. And then this other number here, or this other part of the box, is called the third quartile or upper quartile. All right, so anyway, that's how they get those numbers. Our job in this section is going to be more about analyzing what's going on than actually coming up with these box plots or box and whisker plots, but that maybe gives you a little refresher on how we would come up with these. So anyway, what we can do is kind of analyze what's happening. One thing the book talks about here is that the median best describes the data because both data sets have outliers. So we could say the median best describes the data if there are outliers. Okay. The problem is if we do the mean, trying to do the mean, if we have an outlier, that mean or average is going to really be changed a lot by our outliers. Okay, for example, we get a 0% because we didn't do an assignment. That's going to really affect our average or our grade for the class. Okay, alternatively, maybe we do better on an assignment than what we normally do, or better on a test than what we normally do. That can positively impact our mean. But overall, if we want to get a general feel for where the stuff is, if there are outliers, the median's probably a good way of looking at that. So the median for Finn's data set we can see is 5, so median of 5 hours a week. And then for Jonah's, median is 7 hours a week. If you're curious about the outliers, I would say for Jonah's school, definitely an outlier is 1. Okay, 1 hour a week of homework, that's probably not sufficient. On fins, it's a little bit more difficult to detect. Again, the book's saying both of these have outliers. I don't know for Finn's school we have so much of an outlier as we do for Jonah's school. So I might disagree with that a little bit. But anyway, median, since the one of them at least had an outlier, let's look at the medians. So you can see with the medians that Jonah's school had a higher median. And so we could just say the median of Jonah's data set was greater. Okay, what does that mean? Well, it means if we look, for Finn's school, half the people spent more than 5 hours on homework, half spent less. Jonah's school, half spent more than 7 hours and half spent less. So a little bit more time spent on average, we might say, in Jonah's school than Finn's school. Again, that person that only did 1 hour of homework kind of hurt Jonah's school a little bit. Otherwise, really, if you look at it, if Jonah's school, if there wasn't the person that had 1 hour, if you look at the box plot, obviously the numbers would all be different a little bit, but the box plot wouldn't even start until 5. Okay? That would be a drastically different looking box plot just by not having that one outlier. The book, I kind of really disagree with this statement. They said the box for Finn's data set is longer, so Finn can say his data is more spread out or has greater variability. Well, variability has to do with more so like the range of numbers. The range on both of these is the same. They're both going from 1 to 11. They both have a range of 10. Okay? So I don't know that we can really say that there's greater variability for one over the other. We can say that, the boxes, we can look at the boxes and say the middle 50% had greater variability in the one than the other. But to say overall the one had greater variability, I don't think we can really say that for this box plot. So on the try it, Kono gathers the heights of a random sample of 6th graders and 7th graders and displays the data in box plots. What can he say about the two data sets? So we're going to compare the medians, and we're also going to compare which one has greater variability. So if we look at these, look at our box plots. And the first thing we're going to do is look at the medians. So this is kind of a close call here, but you can see the median. Again, that's where like these two boxes meet each other. 7th grade, we got a median of 63 inches tall, and 6th grade we got a median of 62 inches tall. So we could for sure, even though it is kind of a close call, we could say the median of 7th grade sample is greater than the median of the 6th grade sample, which we might expect. And then we can look at the next part, asks about which sample has greater variability. Now, unlike what the book did on example 1, I don't want to just look at the box. I want to look at overall. So let's just look at the range of both of these. In other words, the highest minus the lowest, which you can kind of just visualize on this one without actually figuring out the numbers probably. So on this problem, 7th grade sample has greater variability. And again, we can kind of just look at this because just looking how wide this box plot is compared to the 6th grade one. I don't even really have to figure out any numbers because really the shortest 7th grader was shorter than the shortest 6th grader. And the tallest 7th grader was taller than the tallest 6th grader. So definitely a bigger range. We could figure out the exact numbers if we wanted to, but 7th grade definitely has greater variability here. So the book is going to talk here a little bit about interquartile range, or IQR. That's the difference between the upper quartile and the lower quartile. So you just figure out the upper quartile, look where the top end of the boxes are, and the lower quartile is where the boxes start at, and you just subtract those numbers, and that's the interquartile range. The book is trying to paint the picture that interquartile range tells you about variability overall. But to me, it really only tells you about the middle 50%. Okay, higher IQR means more variability and less consistency for the middle 50%. It really doesn't necessarily tell me about the whole thing, but for sure, if the boxes are wider, basically we could say there's more variability in the middle 50% of our data. Example 2, Finn and Jonah analyze the measures of the center and variability. Do these measures support Finn's assessment of the two data sets in example 1? So if you look at this, we can kind of look at the median. So median for Jonah's is greater. The book's looking at the middle 50%, and so interquartile range they talk about here basically is, where our boxes start and end. So for Finn, the boxes start at 3.5 and they go up to 6.5. If you subtract those, 6.5 minus 3.5, that's how they got the interquartile range like we talked about. Jonah's goes from 5.5 to 8, and if we subtract those, is how they got the 2.5 interquartile range. So the book's trying to say that Finn's had a bigger interquartile range, so it has more variability. Again, to me, the variability is the same. If you want to argue anything about it, you could say that interquartile range for Finn's is greater, so there's greater variability in the middle 50% of the number of hours they spend on homework. Just the middle 50% that really tells us about, not the overall picture, because overall the variability is the same for both classes or both surveys.